Hey everybody, so hope you're all doing well with our new stay-at-home orders and just wanted to this lesson is going to be a little bit more strictly content, kind of get you some information about it. So let's kind of go ahead and get started. So this is going to be a lesson about the solar system. We're going to be starting out at the sun, working our way out, and really just want to kind of give you some interesting pieces of information, spend a little bit of time talking about Pluto, talking about some other things within our galaxies. So let's kind of go ahead and get started. So at the center, we have the sun. Now, there's a lot of interesting little things about the sun. So we know it's the source of all the life on Earth. Without it, we wouldn't be here. Now, ancient civilizations also knew a lot about this as well, too. So Ra is an Egyptian sun god, which was one of the most important gods in the Egyptian, religions. And so they knew then that the importance of the sun and what that fact that we wouldn't be here without it. So the energy is actually generated within the core. It can take up to about 1 million years for that energy to kind of come out because of all the different collisions and all the stuff that's happening. That temperature at the core is about 15 million Celsius, and the pressure is about 340 billion times that of the Earth. Now, what's also interesting about this is when scientists were studying the sun early on, they were trying to figure out what was the energy source rather, how did it have the energy? And they thought maybe it was a huge piece of coal, and they realized, well, it would only last for about a couple of tens of thousands of years, and it's not long enough to have the life here on Earth. So the reason we actually have nuclear energy was because scientists realized that there had to be a different type of process happening in the sun, which gives it the energy. So we have that process of what's called nuclear fusion. So in these cases, you have hydrogen atoms coming together at such intense pressure, such intense speeds, they collide, they stick, that releases energy. Now we actually know that the sun is actually a fluid, it's not quite a solid. And we know this because if you actually look at images of the sun and how it's rotating, it takes about 36 days to rotate in higher latitudes, but in equatorial regions, it's only about 25 days. So the only thing that it can really do that is if it's a solid. I mean, if it's a fluid, not a solid. Now, what's interesting about this is this actually creates some pretty strong and actually warps the magnetic fields. And it's every 11 years that these magnetic fields, you get high spots with them. So they switch every year. And the sunspots correspond with the magnetic fields with it. And the sunspots, just like the magnetic fields, how they switch every 11 years, the sunspots get a maximum once every 11 years. Now, one of the big things we talk about with the sun is, rises in the east and sets in the west, and it actually doesn't quite do that. So you see it kind of moving. If you ever, like for our house, for example, when we have the sunsets, we see the sun setting at different parts and times and different spaces throughout. So you've all already had this, how you can turn STEM into STEAM. You've already seen the art integration with it, so we're not going to spend any time on this. But I did want to talk about the inner planets. So starting off, we're going to go from the center, work our way out. So Mercury. Now, if you think about the Mercury, a lot of the planets were named after Roman and Greek gods. So if you can think about who was Mercury, well, Mercury was the messenger. Mercury is the one that actually moves the fastest across the nighttime sky. Now, it is closest to the sun, but what's interesting is that even though it's the closest, it's not the hottest. Now, we talked about how that it moves so fast, it takes 88 days to go around the sun once. So, if I'm 42 years old, 43 years old, it takes, 88 days to go around 1 year. That's roughly four times Mercury goes around the Earth or goes around the sun is what it takes the Earth to go around. So I'd be like 160, 170 on Mercury. Now the temperature ranges, even though it's not the hottest, it does have the greatest spread in temperatures. It goes from 430 to the side facing the sun down to a negative 170 degrees Celsius. So that's a 600 Celsius degree temperature shift, which is pretty drastic. Very little atmosphere. Now Venus is actually the hottest planet. We call this the evening star. Venus, if you remember in Greek mythology, was the goddess of love. And you got to remember that when the ancient Greek astronomers, they were very good at astronomy, but they didn't know exactly know what they were looking at. So they thought they were looking at these were the heavens, this is where the gods lived. So Venus was the brightest object in the nighttime sky. So this is where the goddess of love had to reside. It had to be beautiful there. So in fact, though, it's actually, let me show you. Hold on one second. Okay, so as I was saying with Venus, one of the things about this is that it was, the ancient Greeks would see it most brightest object in the nighttime sky. I think it's where the Greek goddess of love lived. when in actuality, that's not the case. Venus's surface is sulfuric acid. Um, there was a probe sent there, and it was Venera 13, and the probe, as you can read, it says it only survived about 2 hours because one, the intense pressure crushed it. It's about 96% CO2 gases. It's a runaway greenhouse effect. And that intense pressure, in addition to the fact that the surface is sulfuric acid, there's actually volcanoes on it that spew out sulfuric acid. So this is one of the few photos ever of the surface of Venus because the probe really didn't last all that long. So Venus actually has the high temperature of 460 Celsius because of that runaway greenhouse effect. Because it's so big, because it's like, when you sit in your car in Florida, yeah, it's hot in Florida, but you sit inside your car with the windows up, it's a lot hotter inside your car. And that's kind of what happens on Venus, except instead of your car, it's the entire planet like this. So another interesting fact about Venus is that it takes 225 days to circle the sun, but it rotates once every 243 days. So think about that for a second. What does that actually mean? That it takes 225 days to go around the sun, but 243 days to make one revolution. And it actually rotates clockwise. A lot of active volcanoes on here. Now, Earth science, there's a lot of different things we can talk about it. It's the first planet of the inner planets with a moon. In fact, our moon is fairly large in size when you compare it to the other ones of the inner planets, which Mercury and Venus didn't have any. Mars does, and we'll talk about those two. So we could talk about Earth science and all the interesting things here, but this is where everything is just right for us to be able to be here. So talking about the moon, our moon is kind of unique compared to everything else. Okay, so the website in this link isn't quite working, so I found a different one. If you go to moongiant.com, hyperspace birthday-moon, and you can actually figure out what was the phase of the moon on the day that you were born. So let's just pick a random date. I don't know why mine doesn't want to come up, but I'm going to go January, let's say 8th, and type in a year. That's not my birthday, just so you know, that's the year, but I wasn't born on the 8th. So if you look at January 8th, 1987, what it'll do is it'll come up and it'll tell you the phase of waxing gibbous. And it's also in the constellation Taurus, which we'll actually get to in a little bit about, what constellations actually mean. Now, it's interesting in that the moon that we have is fairly large. And normally you don't have inner planets with moons this large. So we actually think it was the result of a huge collision between two bodies forming at the same time, and the Earth was bigger, and they kind of collided to each other, and the Earth went out, and the moon just kind of got held into place with it. So some other interesting facts about the moon is that there's no crustal plates on it, so there's no erosion, with the exception of meteorites. So the only thing that's going to change the surface of the moon is a meteorite. Now we also know that we did our little experiment before. We know the moon is smaller. It's about 1/4 the size, which actually then results in a gravitational force about 1/6 that of the Earth. Now what's also interesting is that the same side of the moon faces us all the time. So when you look up at the moon, you see the same thing of the moon. Now what about the other side? No, we're not talking Pink Floyd, Dark Side of the Moon, Back Side of the Moon, or anything like that. But what's actually interesting about it is that the back side of the moon looks like a big eyeball. So I want you to stop and think for a second. If this was what was facing us at night, would that change anything about us? Now, this is going to be one of your questions in your worksheet, so stop, take a minute, reflect on it. Okay, now that you kind of reflected upon it, first, physically, would anything change? No. The moon doesn't affect the season, so don't, hopefully you didn't answer anything like that, but the tides are affected by the moon. Now, the moon is still the same mass, it'd still be the same distance away, it doesn't really care which side is facing us, so that's not going to change. But think about the moon in terms, and again, we're talking about Greek cultures, Egyptians, Romans, a lot of the ancient mythologies believe that the stars guided our fates. So now all of a sudden, you have this huge eyeball looking at us. What would be different? Well, think about our cultures, think about our traditions, our religions. You have, during a full moon, the eye is watching you. Maybe that's a good thing. Maybe that the eye is protecting you. Or maybe it's, it's something, evil and it's sinister and everyone has to be inside their homes and nobody leaves their houses at night because of the fact that this eye is now watching to see, are you where you're supposed to be? Or maybe, when it's a new moon and there's nothing there. It's like the eye is closed. It's Mardi Gras. Go out, get crazy, wild times. Because no one's watching you now, so you're not going to get in trouble because no one's watching you. So those kind of things would definitely have an impact. So how do we get the phases of the moon? Well, we're going to do another little video that I'm going to implant with this, and I'll give you the link for it, which is a good demonstration about the phases of the moon. Now, if you might have asked an elementary school teacher, why do we have the phases of the moon? They might have said, oh, well, it's because of the shadow from the Earth. And that just sends a cringe down my spine because no, it's not. What happens is, and you'll see this really clearly described in the other video, is that you're going to get light here bouncing off the sun, and that sun gets reflected, or that light from the sun gets reflected off. So the whole idea about vampires burning up into, because of the sunlight, well, technically if they're out at night, that light from the moon is sunlight. So I don't know if it's just too weak to fry them or whatever, I don't know. But it's reflected light from the sun that gets bounced off the moon is what we see. And I'm going to show you another video to help kind of describe that. So the last of the inner planets is Mars. Now when you think of Mars, again, think of mythology. Who was Mars? Mars was the god of war. Well, Mars is a red planet. When you actually look up it, you can see that it's red. So Mars is similar to the Earth in many different ways. In some ways it's different. It takes 2 years to go around the sun compared to us. It's slightly smaller than us. It does have a core. It has a mantle, has a crust, just like we do. There is an atmosphere. It's slight, but there is an atmosphere of carbon dioxide. The temperature is not that different, 30 down to negative 130. A day is similar. So you can see where it's like, okay, there's, why people might want to inhabit it because it's not too different and it's hospitable as long as we can actually find water. Now, Mars was also a big source of science fiction. And that started with once we got telescopes, and instead of looking at our neighbors with their telescopes, we actually turned them up to the skies and started looking at things. We found some interesting things on Mars. So what did we see on Mars? Well, we found channels. Now, some people started assuming that these channels were waterbeds, or that these were actually rivers, or that these were actually made by some type of intelligent creatures because they looked like an irrigation system. Well, if something made them, then that meant something had to be there, and something was intelligent in order to do that. So this really started the whole science fiction. When I think of science fiction, the fundamental, movies, and actually it wasn't even a movie, was War of the Worlds. And I'm not talking the Tom Cruise version because that's kind of, we're not going there. But the original Orson G. Welles version was a radio broadcast. So before television, before internet, before movies, people listened to the radio, and that's how they received their news. So Orson G. Welles thought it would be a great practical joke to do a news broadcast, to do, what would a simulated alien invasion be as if it were a news broadcast? Now, there was an announcement made before the episode aired in that this is not real. But they did a news broadcast as if aliens invaded from Mars. And that was one of the premier science fiction things. Mars has 2 moons, which going with the Mars with the god of war, you have Phobos and Deimos, which is the god of fear, god of terror. Sometimes Mars also experiences retrograde motion. And what does retrograde motion means? Well, it goes backwards. So we already talked about science fiction, War of the Worlds, the channels, that all went away. But then, as a doctoral student, sometimes you kind of get menial jobs where there's not much going on and it's just kind of boring and tedious work, but you got to do it because, you're getting your tuition paid for. They were examining photographs of Mars. And then all of a sudden, in one of those examinations, this is what popped up. So this face on Mars reignited the whole science fiction community. The, whatever conspiracy theorists, the idea that there was life or something on Mars. You see here, there's the eyes, there's the nose, there's the mouth, there's the chin. Now, there is a psychological condition that we attribute humanistic characteristics to inanimate objects, and that could very well be the case, but let's get real. This is a face. So we're going to start talking about the outer planets in the next video. So I'll see you then.